Now let us extend the problem. In the previous problem, every A has to be followed by B. Now let us say A should never be followed. A should not be followed by BB, which means now in the language I don't want any BB after an A. So is this language complement? Let's write down the language. Let us call the previous one as L1 and this one as L2, right? So in L2, A should not be followed by BB. What happens with sigma epsilon? There is no B at all, there is no A at all, so it is okay, it is allowed, because A, there is no A, therefore A is not followed by BB, right? What happens to all B's? Yes, they are allowed because there is no A at all, so I need not check anything, right? And now if I get a, it can be allowed because it is not followed by AA. If I get AA, it can be allowed, AAA it can be allowed, so on, or AB is allowed, AAB is allowed, so on. So are these two languages complements of each other? They are not complement because we have epsilon in the intersection and many number of B's are in the intersection. Therefore, both the languages are not complement. So we have to again do the DFA. Fine. So first thing is I have to accept the epsilon. Therefore, initial state equal to final state. And in order to solve this, we have a key. The key is if A is followed by BB, I should not accept it. If there is single A, I'll accept it. If there is AB, I'll accept it. But if it is followed by one more B, I will not accept it. Single A, I'll accept it. Single AB, I'll accept it, but ABB, I'll not accept it. And once I see A followed by two B's, I'll never come back. So it is going to act as a dead state. Okay. Now is this a DFA? It is not a DFA because we didn't show what happens for all states. What happens if I see B here? If I see any number of B's, it is nothing but all B's, therefore I have to accept it. What happens about if I see an A here? See, if I see any number of A's, I should be accepting it because B's followed any number of A's is nothing but A followed by any number of A's and there is no change in the number of B's. Okay, so I am going to accept it. What happens if I see A here? If I see A here, it is nothing but A followed by 1B, and if I stay here itself and if I accept all A's, the problem is if I accept all A's here, the problem is the A, when it is followed by single B, it will be rejected. Therefore, this is not the state in which I have to accept all A's. I have to go back and then accept it. Just think about it. Why shouldn't I accept all B's here, all A's here? If I accept all A's here, now if any A is followed by single B, it will be rejected. But then I want a condition that if an A is followed by two B's, I should reject it, and if A is followed by any number of A's, I should accept it, and if the A is followed by single B, I should accept it. So if I am here and if I keep on looping for A, all the A's followed by a single B may get rejected. That is why I have to go back and accept it. Now check it, it is a DFA. For A, we have shown what happens on A and B. For B, we have shown what happens on A and B. And for C, we have shown what happens on A and B. For D, we have shown what happens on A and B. In fact, D is a dead state. So this is the answer.